The moment you receive such a question, ensure that two things. Read the question 2 times. And on the third attempt, start summarizing the number somewhere, if it's to do especially with question 2 and above. But question 1, they are usually questions related to the mean, mode, median, measures of central tendency, measures of dispersion, and skewness measures. Those are the common questions in question number 1. So amongst the measures of central tendency, we also have a weighted mean. And I believe you guys are already conversant with the weighted mean. So when you read that number, when you keenly read the number is saying 2 candidates, Amina Brian, sat for 3 professional papers, accounting, management information system, audit and assurance in the May 2027 diet. Now, what the examiner gives you is something complex. I believe you know how to calculate the weighted mean, but I usually tell my students that professional exams go beyond mere calculation of the weighted mean. They test for other attributes. For example, assuming that the mean now is given to you, can you determine a missing value? And those are the questions you should always expect in the professional paper. So don't expect anything short of that. They must give you at least a question where you can probably deploy excellent quantitative skills. Now, in such a number, if you look at such a number, the examiner is mentioning 2 things. Examiner is giving you already a computed mean. All right, he's giving you already something computed. If not computed already, is giving you tips on how to work around the number. So they are telling you there are 3 candidates. That's Amina Brian and Brian, but they sat for 3 papers. What you do in the exam is to go to the required part of the number. Do not start a number unless when you have fully understood the required part of the number. So the required is determine the value of y for which Amina and Brian obtain the same. Determine the value for which Amina and Brian obtain the same weighted mean score. So first things first, in chapter 1 questions, the first thing you do as step number 1 is to politely come and write the formula. So you say weighted mean is equal to, open the back of your question paper, is equal to, so if it's not at the back of your question paper, this is something which is easy to cram, summation of anything which is given to you, which is x multiplied by its weight, divided by summation of weight. So by and large, that is the formula we are going to deploy. But the examiner has been very clear, telling you that these 2 candidates have got the same weights. Question is, who are these 2 candidates? The examiner is telling you Amina and Brian have the same weighted mean score. So you come clearly and say, but weighted mean for Amina is the same as weighted mean for Brian. So the more you read the number, the more it sinks on how to work around the number. So you kindly come and say, weighted mean for Amina is the same as weighted mean for Brian. But how can I get the weighted mean? Because the weights are the same. So you come and deploy Amina, and you say, I have the marks for Amina. What are the marks for Amina? Amina has got X. These are the marks. So you deploy and say marks, which is our X. So Amina's marks are going to be called X. And then you have the weight, which is going to be called W. So we have 3 papers. Amina got 75, and that one generates a weight of 3. Amina got 68, and that one generates a weight of Y. The same Amina got 54, and that one generates a weight of 2. So you are already aware that a weighted mean is getting the X value which is the max multiplied by the weights. So we do proceed and do the multiplication. So put on your calculators 75 times 3, so that at least you're good to go. So on your calculator, 75 times 3 is giving you 225. So this is 225. This is 68y. This is 54 times 2, 54 times 2, which is 108. Our interest is always in what is the formula. So the moment you get what exactly is in the formula, then you are good to go. So you have the two candidates, Amina and that one. Ensure that you get the summation of weights, which is equal to 3 plus y plus 2. And ensure that you get the summation of max times weight, which is equal to 225. That is 225 plus 68y plus 108. So that summation is going to govern your weighted mean. These attributes here are for Amina. Now you repeat the same, and I'm going to use a different color for Brian. So repeat the same, but now for Brian, what is the weighted mean for Brian? So we are going to repeat the same, but this time around, we are going to talk about Brian. So you come again and talk about Brian's marks. These are Brian's marks, and Brian's marks, I'm calling them X. Brian's marks, I'm calling them X again, but the weights are remaining the same. So we just have W, or we just have X times W. So this is X. So this is X multiplied by W. So we have 2 marks. So we just have X multiplied by W. But this is strictly for Brian. Brian has which marks? Brian has a 60, and the weight is a 3. Brian has a 78, and the weight is a Y. Brian has 50, and the weight is a 2. So weights are already there. Weights are already there. What we need is simply W times X. So the first one will be, get your calculator and get 60 times 3. Get your calc, 60 times 3, that is 180. 180. Then this is 78y, and this is 2 times 50. So 50 times 2, it gives you 100. Now, you already have the same summation of weights, but you have different, same summation of weights, but you have different WXs in total. So you come and say, what is weighted mean for Amina? That is summation. So it's going to be 225 plus 108. You come and say 225 plus 108. That is 333. So you have for Amina 333 plus 68y divided by, what is your weight? Summation of the weight is 5 plus y is equal to, how about for Brian, that is 180. For Brian, it will be 180 plus 100. That is 280. So that is 280 plus 78y divided by, again, 5 plus y. Now, when you do cross multiply, these ones down are going to cross over. Or when you cross multiply, the 5 plus y is going to be crossed out. Why should 5 plus y be crossed out? Because they are more or less the same. So 5 plus y is going to die. And then you will remain with something interesting. 5 plus y dies. We shall remain with the 333 plus 68y is the same as 280 plus 78y. So you know the mathematics very well. We can transfer this one this side and that one that side. So what is 333 minus 280? So you come in your exam, and then we have 333 minus 280, that is 53. So we have 53 is equal to, what is 78 minus 68, that is 10, equals 10y, divide by 10, divide by 10. So definitely our y is equal to 5.3. So that is how simple the number is. That is how simple the number is. That is how simple the number is. So please do not fail such numbers. These are very basic numbers and you must understand the formula. So before you start on number one, the first thing you do is to obtain the formula. I repeat, question number one, to do with measures of central tendency and measures of dispersion. The first thing you do in the paper is to obtain the formula. Without the formula, you surely cannot move. So you can now proceed and calculate Brian's weight. How about question number two? The following table shows the number of students falling into different groups for the ICPAU Paper 3 test marks given at MAT Abacus. In total, there are 105 students, and the number of students who scored between 10 and 20 are missing. Question is, a model mark was provided to you, and the mode provided to you is 24. I repeat, these are the kind of questions you should expect at professional level. I repeat, these are the kind of questions you should always expect at professional level. They must give you a computed mean. They must give you a computed mode. They must give you a computed median. And then the examiner is asking or is finding out whether you know how to obtain the missing value. So let's try and see. Let us give it a short try and see. When you keenly read the number, you first put it vertically. It's better to solve such numbers in vertical form. So let's get started. Question number two. It's better to get started. Question number two. You have the marks. And after the marks, you have the frequency. Okay. You have the marks and then the frequency. The marks are 0 to 10. The next one is 10 to 12, 10 to 20. Next one is 20 to 30. Next one is 32. This is 20 to 30. This is 20 to 30. The next one is 30 to 40. And the next one is 40 to 50. So it is usually very nice to arrange your marks in a vertical form. It's through this that you can easily solve the number. Then the frequencies are 14. You have a K, you have 27, you have R, and then you have 15. Now the examiner is telling you that the mode has already been computed. Your examiner is telling you that a mode has already been computed. Please note, what I'm telling you is what will appear on that day. The moment a question is set and there is only one missing value, you note that there's going to be one equation. But when there are two missing values, please note there are going to be two equations. Read the number over and over. You'll understand why we are saying there are going to be two equations. For example, here they are saying summation of the frequency, all numbers are totaling to 105. All right. And they are telling you that the mode has already been computed. Mode has already been computed and is equal to 24. So if the mode is being computed already, there's nothing much you can do apart from looking for where 24 lies. So within the marks, where does 24 lie? Definitely 24 lies here. And 24 lying here implies that that is the model class. So already mode is computed as 24 and we are being requested to compute the missing marks. So you smartly come in your exam and you say mode is equal to 24, which is equal to, formula is LM plus D1. And by the way, this formula is provided at the back of the question paper. All formulas are given at the back of the question paper. There's no need for you to struggle recalling the formulas. So mod is equal to LM plus D1 over D1 plus D2. Multiply this by C. Right? I hope you guys, we are still together. So your D1, according to the formula, your D1 is the difference between frequency of the model class. This is D1, frequency of the model class, and the one above it, which is 27 minus a K. And your D2 is this one, where D2 is equal to frequency of the model class minus the one below. So that's where we start off with computing the mod. This is where we start off with computing the mod. So we proceed and say our 24, which is the mod, is equal to LM is the lower class boundary of the model class. A boundary, these kind of classes are called exclusive classes, where you have the upper class limit being the same as the lower class limit. Those are exclusive classes. There's no need of subtracting or adding 0.5. So we shall have 24 is equal to, what is the lower class boundary? That's already a 20 plus the D1. The D1 is 27 minus K. And again, another D1 is 27 minus K plus D2 is 27 minus R multiplied by C. C is purely a calculator difference between 20 and 10, upper and lower, so it is 10. So our basic area of interest, transfer this one this side and subtract off. So on the sides, to save on your time, you know very well that 27 minus K plus 27 minus R will give you, that is something which you put on the sides. So what is 27 plus 27? You smartly come and compute. What is 27 plus 27? Smartly computing 27 plus 27 on the calculator. 27 plus 27 gives you 54. So we shall have 54 minus K minus R. So 24 minus 20 is a 4, being equal to, this 10 only multiplies the numerator. I repeat, never multiply 10 by the denominator. So it is 27 times 10, which gives you 270. So you have your 270 minus 10K divided by 54 minus K minus R. This is over 1. So that's where we apply the principle of cross multiplication. We now apply the principle of cross multiplication, and you'll be happy to learn that a 4 into brackets 54 minus K minus R is the same as 270 minus 10K. All right, so multiply 54 by 4. So we shall have 54 times 4, which gives you 216. So you'll have 216 minus 4K minus 4R is equal to 270 minus 10K. So we put likes together. This side, we can leave the K and we transfer 216 this side. Then we bring the 10K this side. So we shall have 10 minus 4, which is 6K. So by and large, you'll have 6K minus 4R being equal to, what is 270 minus 216? 270 minus 216 gives you 54. So this is equal to 54, and call this equation 1. I told you something, and that something was, the moment the examiner gives two unknowns, simply know that we are going to generate two equations, and you have just generated the first equation. The second equation comes from the total frequency. The second equation will come from the total frequency. What is the total frequency? This is equation 1. Total frequency says that 14 plus K plus 27 plus R plus 15. This one must give you 105. So you add them. You do add them. That is 27, 14, 14 plus 27 plus 15 equals to 56. So what is 105 minus 56 gives you 49. So we have K plus R equals to 49, and this is equation number 2. So our task in the exam is to solve the two equations simultaneously. You have the right to let R be equal to something, or you can get another way of getting the value. So we have 6K minus, so you have 6K minus 4R is equal to 54. And then you have a K plus R is equal to 49. These are the two equations which are prevailing now. So we can just make this one a 1 and this is a 6. We are using what we call elimination and substitution method. So we shall have 6K minus 4R is equal to 54. 6K plus 6R is equal to, what is 49 times 6? Your calculator should be handy in the exam. So 49 times 6 gives you 294. 294, so subtract off to eliminate the K. So we shall have 4. Negative 4 minus 6, that is negative 10R, being equal to, what is 54 minus 294? 54 minus 294, which is 240. This is 240 negative, so divide by negative 10, divide by negative 10, so meaning your R is equal to 24. Your R is 24. Watch carefully and see how I am computing those numbers. It is something very, very basic. After getting R as 24, you now proceed and substitute. After getting R as 24, you can now smartly proceed and substitute. You know very well that K plus R is equal to 49, but your R is 24. So that means K plus 24 is equal to 49, meaning your K is equal to 49 minus 24. So your K is equal to 49 minus 24. So your K is a smart 25. Please make sure you don't forget that in the paper. Next question, I may do for you just a few questions. I'm just giving you tips so that you practice. Let's just read normal distribution tables. Let's just read normal distribution tables. Assuming such a question is set to you in the paper. This is testing whether you know, 1, how to read normal distribution tables, but even 2, which is most crucially important, something which is important, do you know how to interpret? Do you know how to interpret some questions and make them like real business scenarios? Because the examiner is assuming that you know how to make good interpretations. So let's get started. An examiner is telling you that the ICPAU has analyzed the performance of candidates in a recent sitting and summarized the results as below. How has the examiner summarized the results? They are right there. The examiner is telling you that 12% passed with a distinction, 58% passed without distinction, and 30% indeed failed. But a person can only fail if they score less than 45 marks. And a person can only get a distinction if they score above 80. At least 80 means from 80 and above. Assuming that the distribution is normal, do X, Y, Z. So let's understand, how do we now tackle such a number in the exam? This one has already been summarized. There is absolutely no need for you to start summarizing the exam question. What is relevant in the number right now is interpreting it. I repeat, what is relevant right now is you. Do you have the capacity to interpret the number? If you don't have the capacity, then please, this number might be difficult for you. What interpretation is the examiner looking for? Can you put this on a normal distribution table and illustrate? Maybe a simple tip I can give you. The moment the examiner gives you issues of marks less than, marks greater than, then just know at the end of the day, they're asking for the mean and standard deviation in marks. And when they ask the mean and standard deviation in marks, do not even think, simply know that they are looking for two simultaneous equations which can be solved. One equation is got from the lower side and another equation is got from the upper side. So the number has already been summarized. Your role is to do a thorough interpretation and representation on the normal distribution curve. So listen and listen carefully. Telling you 12% scored, 12% passed with a distinction, 12% passing with a distinction. So what we do, we say, if 12% passed with a distinction, when does someone pass with a distinction? Can they get a distinction when they are scoring lower marks? Of course, no. So you come in step one and say representation. Come to step one and say representation on the normal distribution table. Normal representation on the normal curve. Make sure you carry a ruler. Make sure you carry a ruler and draw a very good normal distribution curve. Like I told you in class, the normal distribution curve is always flatter. It is flatter than the T curve. I repeat, the normal distribution curve is slightly flatter than the T curve. So when you're drawing the normal distribution curve, mind about the flatness. And two, never ever join the curve. The curve doesn't join the x-axis. And I've already been telling you that 1,000 times. A curve does not join the x-axis. And I've told you that 1,000 times. So as you draw your curve, be careful so that you are not, you don't lose out on any marks. Right in the middle, you have the mean is equal to M, and you have standard deviation is equal to SD. Now they are telling you that there are marks which are below and there are marks which are above. So which one is below and which one is above? The ones definitely which fail, they score below the average mark. And those ones which score below the average mark are 30%. So this is 0.3. What you should know is that there's no examiner who will tell you that the probability is 0.3. They will bring it in examination setting form and say 30% of students failed and 12% of students passed. 30% failed, but 12% passed. So this is 0.12, which is 12%. That is the examination language they will use. Call this X1 mark, call this X2 mark, and your X1 mark, those ones who failed is already given there in bold. The examiner said a candidate who fails is scoring less than 45 marks. So definitely this is 45 marks and you must get Z1. Then the examiner is also saying a candidate who passes scores 80 marks. So you must get Z2. Please note, our Z values, we read them using a process called standardization. Now this is destandardizing. To destandardize, it means the examiner has already computed for you the probabilities. To destandardize, it means the examiner has already computed for you the probabilities. And what is interesting is that the examiner now wants the examiner has computed for you the probabilities and wants you to work backwards and get the Z value. So some of you would be asking, how do you now get the Z value? Please don't read 0.3. The tables which are provided to you in your exam, they read this value, this one. If you open your examination table, that is the value they read, because half the curve is 0.5. Half the curve is 0.5. All right, so what is 0.5 minus 0.3? Definitely this is 0.2. What is 0.5 minus 0.12? So you go to your calculator. If you feel you can't not see it thoroughly well, you say 0.5 minus 0.12. That is 0.38. So this one is 0.38. So we go to step number 2. And step number 2, you know that your Z value, your Z is equal to given value x1 minus the mean value divided by standard deviation. So before you proceed, go to your examination paper. Go to your examination paper. At the back of the question paper, I'm just using one simple paper, but at the back of your paper, go down up to where you see Z value. This is the Z value. So this is your Z curve. Like I told you, the Z value or your Z curve reads only this area P. This is the area which it reads from 0 up to Z. So we are looking for a Z value corresponding to, we are looking for a Z value corresponding to 0.20. It's actually supposed to be 0.20 or something which is very, very close. So we are looking for a Z value which corresponds to 0.20 or something which is very, very close. So kindly go to your examination table and read throughout. We are looking for 0.20. So let's see, where can we have 0.20? Let's see, 20. So you move. Let's try 0.5. I'm seeing it's closer here. 20. Look at this, no. Look at this, no. Look at this, no. Look at this. Look at this honestly. This is more sharper. This 1985 is close because when you round off this, it becomes 0.200000. So be a fact that you have a 9 and 8. That is more sharper. So we are looking at 0.54, 0.52. We are looking at 0.52. Now, if you are to make any additions, which should be purely up to you, you could say, what if I add there a 14? What if I add there a 14? But it doesn't matter. You can stop at 0.52. And mind you, because it's on the negative side of the curve, this one becomes negative 0.52. All right? So we shall have a negative 0.52 being equal to x is already given as 45. X is already given as 45 minus the mean divided by standard deviation. So this is over 1. You'll have 0.52 negative is equal to 0.52 because it's on the left side. That's why we make it a negative. So you have negative 0.52 SD is equal to 45 minus the mean. And this is your equation 1. Then we also now go to equation 2. Using this, you read 0.38. You read 0.38. So what Z value corresponds to 0.38? What Z value corresponds to 0.38? Let's check it out. Let's check it out. Which Z value corresponds to 0.38? Let's see. 3 is down. 0.38. I'm seeing 36, 37. we are looking for 0.38. Is it this one? We are shifting a bit, but we are looking for 0.38. 1.10. Look at this. Look at this. Look at that. Look at this. This one is more closer. More closer. 0.38. More closer. So it is 1.17. 1.17. And because it is very close, we are going to say positive 1.1, positive 1.17. So we shall have a Z which is 1.17 being equal to x2 minus the mean divided by standard what? Deviation. And when we cross multiply, what does it bring us? It brings us 1.17 SD is equal to x2 minus the mean. Oh, x2 is already known. X2 is already known as 80. So 1.17 is equal to x2 is already known as 80 is equal to 80 minus the mean over SD. So is equal to 80 minus the mean, and this is equation 2. Now we have our two equations, and this is what I told you earlier. Earlier, I told you that as long as there are two missing values, always fight to generate two equations. When there are two missing values, always fight to generate two equations. So the equations are, we are now on step number 4, negative 0.52 SD being the same as 45, being the same as 45 minus M, or we can even start it from the other way around, but it's well. Another one is 1.17 SD being the same as 80 minus M. Now, if you're uncomfortable with this arrangement, you could start off with the M so that you can subtract, or you use elimination and substitution method. So let's have, starting from M, this is 45 minus the mean is equal to, 45 minus the mean is equal to negative 0.52 SD. And then this is 80 minus the mean being equal to 1.17 SD. All right. So what we want is elimination. You can eliminate by simply subtracting because the M will die automatically. So what is 45 minus 80? So you go to your calculator and get 45 minus 80. You get negative 35. So negative 35 is definitely equal to negative, and negative is a negative, but in a bigger value. So 0.52 plus 1.17. That is 1.69. So this is equal to negative 1.69 SD. Divide by negative 1.69. Divide by negative 1.69. I'm just giving you a tip that your SD is equal to. I think this should be our last question so that I don't overbug you, but we are going to release more of these. So 35 divided by 1.169. I'm seeing 29.9, which is approximately 30. 29.9, which is approximately 30. I strongly believe we've not made any mistakes. What was the SD value? This is 30. And then what was the mean? Then you replace and get the mean. That is 80 minus M, or 80 minus M is equal to 1.17 SD. So 80 minus M is equal to 1.17 times 30. So negative M is equal to, this is 1.17. 1.17 times 30, then minus 80, negative 44.9, negative 44.9. So our M is negative 44.9. Our M is equal to 44.9, which is approximately 50. Let's do the double check so that we are sure there are no mistakes one by one. So when you read off the value, from the table, the first Z is negative 0.524, but we stopped on negative 0.52. But the best one would be 0.524. So is equal to 45 minus M. So that one generates 45 minus M. It generates 45 minus the mean is equal to negative 0.54. So your equation would be 45 is equal to negative 0.54 plus M, which is, any equation you can be there. Then the one of 0. Oh, I think we made a mistake on 80. I think we made a mistake on 80. 80, they said the examiner was very, very vivid on 80. Let's see. Did we make a mistake on 80? Did we make a mistake on 80? They said they score, a candidate attains a distinction if they score at least. We are correct. They said if they score at least means more than 80. So we are 100% correct. At least means more than 80. So that means the Z is 1.17, and then you have your 80. So when you read from the normal distribution curve, you get 1.17 is equal to 80 minus M. 1.17 is equal to 80 minus M. So that means 80 is equal to 1.17. That means 80, the 80 which is here is equal to 1.17 plus, now when you transfer this 80 and push it on the other side, it becomes 1.17 standard deviation is equal to 80 minus M. I hope you've got how this equation comes into place. 1.17 is equal to 80 minus M. Now, when we transfer, you can either solve it that way or you can bring the unknowns together for easy solving. So that's why I said here, 45 minus M is equal to negative 0.52 SD. And then 80 minus M is equal to 1.17 SD. So to eliminate M, you can just subtract. To eliminate M, you can just subtract. That one can also work for you if you want. So 45 minus 80 or 80 minus 45, whichever way you prefer, you will still get the same answer. So 80 minus M. So I don't know which method you'd prefer, but when you reach there, you can either use elimination or substitution method, but I can guarantee you the answers are going to be the same. I simply wanted to try it for you so that students who have different approaches can still have the same answer. You don't need to have the same way of solving these two equations. This is what I mean. If a student prefers to put the unknowns together, so be it, no problem. You still put the unknowns together and all will work out very, very well. So if that's what your preference is as step number 4, if that is exactly your preference, then you'd put the two unknowns together. And when you put the two unknowns together, the first one will definitely be a 45 remaining alone. So it will be negative 0.52 SD plus the mean is equal to 45. Because you guys want to put the unknowns together. And then the second one would definitely be, if at all, I'll have 1.17 SD plus, is it a plus or it's a minus? Minus plus M is definitely equal to 80. What I have done, I have simply put the two equations and the unknowns together. So when you do subtract, because you want the m's to die, if you want m to die, you definitely subtract. So when you subtract that one, it becomes a bigger value. That one, I repeat, it becomes a bigger value, and that is 0.52 plus 1.17. So it's negative 1.7. So you'll have negative 1.7 standard deviation is equal to 45 minus 80. 45 minus 80 gives you negative 35. So when you divide by negative 1.7, divide by negative 1.7, you'll get your standard deviation as, if you adopted that, it will be 35 divided by 1.7, which is again 20.5. So this one gives you a standard deviation of 20.5. So I'm suspicious. I think we had made a slight mistake. So this one gives us 20.5. And then when you replace back 1.17 times 20.5 plus m is equal to 80. We had made a mistake. So when you're reading, please make sure you make those corrections. So 1.15 is actually 20.6. It's actually 20.6. And then 1.17 times 20.6 gives you 24.102 plus m is equal to 80. So m is equal to, this is equal to that, minus 80. So m is equal to 55.89. So we have 55.89. So I think I should stop here. We've done quite a lot. This is just a tip of what happens at MAT Abacus. The moment for the newcomers or those ones who would like to join, ensure that at least you come to MAT and we do all these numbers. All right. Thank you so much. Bye-bye, colleagues.